Hi everyone, my name is Arjun Gungar and in this video we will discuss the unit 4 of the calculus and in this unit we will see how we can solve the double integral with the constant limit, variable limit and if the region is given, and after that we will discuss how we can solve the double integral and find the area using the double integral, and after that we will discuss how we can use the double integral for finding the volume. And here if we will put the function z equal to fx comma y and that z represent the height, so this will give you the volume of that surface. And after that we will discuss the how we can evaluate the integral using the change of order of integration. And the next topic our will be after that the evaluating integral by change of variable, means here we will discuss only the Cartesian plane to polar plane. And after that our next topic will be evaluate triple integral if limit are constant, and the next is limit are variable. Now let's go to the question and now let's solve the questions. Before starting the question, let me give you the quick summary of the relevant information. So in the multiple calculus, in multiple integration, first you have to remember the quadrant. So what is the quadrant? Quadrant is, we can represent by the 2D dimension x and y axis, and here x is positive axis and the upper side is y is positive and this side is x is negative and the lower side is y is negative. So if you will see here x is positive, y is positive, that means this is first quadrant, and here x, this represent x comma y. So x comma y means x positive, y positive, that means positive positive, and in this side you can see our x is negative and y is still positive, so this will give you negative comma positive, and in this side our x is negative, y is also negative, then this will give you negative comma negative, and this also called third quadrant. And here we can clearly see x is positive but y is still negative, and if you will see x comma y, then this will give you positive comma negative. So in the fourth quadrant we have what? We have positive comma negative. And also you have to remember, and the whole x-axis y is 0, so that's why we also say y equal to 0 is our x-axis, and whole y-axis our x is 0, then we can say, if you will see whole the y-axis x is 0, so x is 0, and if you will see the quadrant at any of the point, then 0 comma 1 0 comma 2, so our x is 0 whole the y-axis. So that's why we can see x-axis is y equal to 0, this y equal to 0, and y-axis we can say x equal to 0. So this is the meaning of the quadrant. Now let's move the next thing. What is single integral represent? We already know the integral represent the area from a to b, and this if we are solving integral fx comma fx dy, and you can understand why like this, integration fx dy and y equal to fx. So y equal to fx is the function and a to b you are going, and this will represent the area. And if I just remove this function from inside this, then what it will represent? So the meaning you can clearly see here, what single integral represent. So integration a to b dx represent the length along the x-axis, means this is our x-axis and here a to b, and this is if a small portion dx, then you can see a to b you are going to integrate, means this will give you only the length. If you will put the function inside, then this will give you what? Then this will give you area from a to b. If there is no function, then this will give you only the length of this x-axis. Same way you can imagine, from if you will calculate dy, then this will give you a to b, length of y-axis a to b, and if you put the function x equal to fy, then this will give you what? Then this will give you area. So only single integral, if their function is present in the single integral, if function is present, then this represent area bounded by the curve fx and axis. So x is from x equal to a to b if your function is y equal to fx. So you can clearly understand why from here. Integration a to b fx dx represent the area bounded by the curve fx and axis from a to b. So that is the meaning of the single integral if function is present, and the single integral if function is not present. If function is not present, then this will give you only the length of axis along, if this is integration along the y, then this will give you a length of y axis, and if you are doing integration along with x axis, then this will give you length of only x axis. Same way you can imagine others. Now let's move on the our next thing, double integral without surface. So if function is not present, so double integral without surface also represent the area, and can be calculated by the double integral dx dy or double integral dy dx. Means how much you are moving on y axis and how much you are moving on the x axis, just put the limit and you will get the area. And if you have the curve, then whatever curve you are, just to put the limit and you will get the area. So here is the classic rule for finding the area. You need to do one thing. If you are taking x constant, then take y variable, and if you are taking y variable, then take x constant. So one thing you have to do when you going to find out the area, and we will see how we can calculate. So our first example you can imagine like this. Our first example is area of circle, center 0 0, radius a, And you can imagine this is the equation of circle x square plus y square whose center is 0 0, center is 0 0 and radius is a, and this is the equation of circle and you have to find out the area. So how you can find out the area? So you can say double integral dx dy, and here one thing you have to do, either take x constant, y limit variable, or y constant, x limit variable. Any of the way you can solve this type of problem. So let's do by the one thing. First, keeping x constant, y limit variable. So from minus a to a, you can clearly say, if you draw the circle and this is the coordinate of minus a comma 0 and this is the coordinate a comma 0. So you are moving throughout the x minus a to a. So that's why our x limit is minus a to a. Now for if x is you are taking, then you have to take the vertical strip, x constant, then you have to take the vertical strip. Then along, because this is not the constant, if this is constant then it will make the rectangle. If this is not constant, then we have to take along which this is moving. So clearly you can see upper side, you can find out the y value from here, under root a square minus x square, this is plus side, and bottom side you can say y is in negative a square minus x square. So your limit will go of y variable is minus under root a square to x square plus under root a square to x square, and this is limit in variable x, then this is y limit. So you have to integrate this dy first, and after that just integrate dx. So if you do, then you can easily find out the value. Or either you can do one thing, just take the first area, just find out the area of this first portion, and after that multiply by the 4. So this will give you all 4 quadrant area, because this is symmetric. So any of the way you can do. So let's move how we can do the next thing by the next thing. Second is keeping y constant, x variable. If you are taking y constant, then clearly see your y is moving also a to minus a to a. So you can say minus a to a. So you can say y limit is minus a to a, and after that x limit, same way, if you are taking y, then you have to draw the horizontal strip, and from here you can find out x equal to, this side x is negative, minus under root a square minus y square, and this side this will give you what, x equal to under root a square minus y square. Just put the limit here, x minus a under root and whatever this limit, and after that just, if this is variable in y, that means this is x limit, and after that just integrate with respect to y and you will get the answer. So this is the two way how you can find out, and the simple way also you can do, first find out the first quadrant area and after that you can multiply by the 4, and this will give you overall area. When we will solve the question, then we will discuss, what here is the basic overview what I want to give to you. So here this is the note for remembering. Same answer will come by solving both the integral, and you already know the area of the circle is pi r square, and here a is r is a, so our answer will be pi a square. And also area of square by using the double integral, surface is not included. So simple how dy and dx is moving, this is the square, then clearly x is moving. If this type of rectangle you have, then clearly you can say x is moving 0 to a, then x limit is 0 to a. And how y is moving 0 to b, so y limit is 0 to b, and this will make a closed rectangle. And for this rectangle you can find out the area, and already you know area of rectangle is length into breadth, a into b, and if you solve this integral, then also you will get a into v. So this is the way how you can find out the area by using the double integral if there is no surface. Also if there is a surface, then you have to put this equation y equal to fx function into this integral. How your x is moving a to b, just put the function, and this is the function, and just put this is the function of x, then just to do integration with respect to x, because this is x limit, and here is the function, then this will give you area bounded by this function and the x-axis, positive x-axis. So you can do by any of the way. Also you can find out by the double integral, you can say your x is moving along a to b, and your y is moving, if you x constant, then you have to take vertical strip, y is moving y equal to 0, because x-axis is y equal to 0, and whatever this function you can say, and this is y, then just do with respect to y first and after that x, and you can find out the area by using the double integral. So that is too much theory we already discussed. Now let's move on the next concept. One more thing I just want to tell you, and after that we will move on the questions. So see, if double integral with surface we have, then this represent the volume. See, if you have the surface, and if you just project that surface in the 2D plane, then after that what you can do, for that the top, whatever the surface, you can just project on the 2D and you can take the volume. So that is the way you can take the volume if this is the surface, and this surface like this also, and after that same, for the same surface you can see, you can find out the volume if you know the x limit. That is the behavior of function, whatever how this upper side is moving, just put the function here, and after that just integrate how the x limit is going, y limit is going, and after that you can evaluate, and this represent the volume if there is function is given. So double integral with surface or function represent the volume. And also you can find out via this formula, double integral fx comma y dy dx, and we will solve most of the question. So, and one thing you also have to remember, by the triple integral also you can find out the volume. Here you have to say how your x is moving, y is moving, z is moving. Any of the way you can say how everything is moving, x, y, z. And if you know how your x, y, z is moving, then just put the limit and you can easily find out the volume of that surface. So let's see how we can solve the question. So before knowing the question, you have to remember the basic graphs. And this is the graph of y equal to x square. And this is the line passing through the origin y equal to x. And this is the circle x square plus y square equal to a square. This is the parabola y equal to x square. You know x square graph. And this is the parabola on the x-axis, x equal to y square. This is the parabola. And if you just draw the line y equal to x, then you can see some of the question you can notice like this also. And if you will draw the line, then you can see some of the question like this also. So these two graphs are very important, y equal to x square and x equal to y square. And also this is also important, y equal to under root x. And if you will draw the line, then this will be the bounded region. We will see when we will solve the question. So let's move on the this PDF I will share to you, and you can notice this is the line y equal to x. If you just add 2, then this line will shift at distance 2 and this will become like this. And if you just subtract minus 2, then this line will come at minus 2 and this line will become like this. And same, if you just multiply by the minus, then it will shift this sign. So now y equal to minus x sign line with this, and if you just add plus 2, then this will go upper side. And if you just put the minus sign again, then this will go the lower side. So this is the way how you can draw the single line. Also, if you have any problem, then just take any of the 2 point. It's better to take one time x0 and one time y0. And if x0, whatever the point, let's say x0 you get 2, then just this is the point. And after that, if y0 you get 2, then this is the point, and just meet 2 point, and you can easily draw any of the line passing through the 2 point. So this is the way how you can draw any of the line. And this is the graph you have to remember, y equal to x square. If you add just 2, then it will shift in the positive distance 2. And if you just subtract 2, then this go below. And if you just draw y equal to x line, then you can see this is the region positive. And if anyone say pole, then this will become like this. So you have to remember the graph, all those graph. I will share the PDF with you. It's not a problem. And if you just shift this parabola at, then this shift the center. Before that, this is center is 0. And now if you just put here, then the center is now shifted at the positive distance. And if this is y equal to x minus x square, then clearly you can see when this will give you 0 if x equal to 2. That means you are just shifting at positive distance, and here also you are shifting on the minus distance. So this is the graph. You can clearly notice y equal to minus x square, and if I will draw the y equal to x line, then this is the region you have to find out. So this is the way how you can draw the region and how you can find out the area, if you already know something little bit. Now let's move on the question, and you can see some of the graph. So this is the question we are now going to solve, and this is the type 1 double integral if limit are constant. So if limit are constant, and if limit are constant, then it's not necessary to check where what is the limit of y or what is the limit of x. If you see here, x is moving 1 to 2. If this is the, if here you can see x is moving 1 to 2 and y is moving 2 to 3, then if this is, you have x axis and y axis, then you are saying x is moving 1 to 2 means somewhere here, and y is moving 2 to 3. Let's say this is y equal to 1, this is y equal to 2, this is y equal to 3, means x is moving 1 to 2, y is moving 2 to 3, and this is the rectangular box for which you have to find out the area, because double integral represent the area, so without function. So you have to find out the area of this rectangle, and you know area of rectangle is L into V. And if I just make the changes in this rectangle, instead of this I just say to you y is moving 1 to 2 and x is moving 2 to 3. X is moving 2 to 3, that means somewhere here. So still your area will be same. So the meaning of that, if limit are constant, then it's not to make any changes in your final answer, because area is always constant. If limit are constant, then you can say any of the way this is x limit, y limit. But the basic thing you have to understand, if there is y, then just say this is y limit, and if this is x, then after that you have to start with the term which is nearby the integral, if not mention. Otherwise, if directly mention which limit is this, then go directly by like that. So we will see how we can solve. If limit are constant, then it is not compulsory. You can start by any of the way. This is x limit or y limit. Answer will come same, but you have to understand most of the time. So see how we can solve this question. And here you can see double integral without the function represent area of rectangle, and here x is moving 1 to 2 and y is moving 2 to 3. And how you will solve this? So first see any of the way you can solve, either with respect to x or y with respect to y, but it's better to start with the term which is nearby the integral. So here the dy is nearby the integral, so start with the dy. So the integration of dy will give you y, and just put the y limit. Y is moving 2 to 3, just put the limit of y, and whenever y is present, just put 3 minus 2. So this will give you 1, 1 will come outside. Now x is remaining. Integration of dx is x. Now put the limit. So this will give you upper limit minus lower limit. This will give you 1. So how you can solve the double integral if limit are constant? Now let's see the next question. So next question is integration. Let's see, this is not given, huh? And there is a function, and you already know if there is a function, and whatever the function is like this, and you can imagine in the that function you can project on the plane and how x is moving, and based on that you can find out the volume. So this question can be formed like this: find the volume of the surface z equal to xy, and x is moving from 0 to 1 and y is moving 2 to 4. This question like can be come like that also. So this is the very simple, because limit are constant, and if limit are constant, then you can say any of the way, this is x limit or y limit. But it's better to say, if this is y is nearby the integral, just better to say this is y limit, and after that the remaining one is will become x limit. Now if you already decided which limit is which one, now just start with the integral which is nearby the integral. So just do the integration. Now with respect to y, now you are going to integrate with respect to y, and if you are going to integrate with respect to y, then treating x as a constant. So you have to treat x as a constant and y is only the variable, because you are going to do integration with respect to y. So treat as a y as a variable and other are constant. So your x is constant. Now your integration of y will become y square upon 2. So your integration is become y square upon 2 and x is constant, and this is y limit. So just to put limit where y present, don't think anything extra. So just put y equal to 2 to 3. Where is y present? You can take xy2 outside and just put the y limit. 4 square minus 2 square. Now you will get 4 square is 16. 2 square is what? 4. Now you left with 12. You can take 12 outside, or you can either just divide. You will get 6. 6 you can take outside. Now you left with x. Now just integrate the x. So integration of x is x square upon 2. Either you can just divide and after that put the limit, or either put the limit and after that divide. So this will give you 3 answer. So this is the way how you can solve the any of the integral with constant limit. That is very easy to solve. And here also you can say find the volume of this function e to the power x plus y when x is moving 0 to 2, sorry 1 to 2, and y is moving 2 to 3. And you already know how to solve. Just put the function z equal to e to the power x plus y. Either you can say dy dx, or either you can say dx dy. And if you are saying dy, so just put the y limit first, and after that x limit. X is moving 1 to 2. So this is the way how you can solve this integral. And if you are going to solve the integral, then you cannot do directly. Just divide by the two part, e to the power x and e to the power y, because you can directly add the base like this. So just divide and after that do the integration. That will make easy. Now if you are going to integrate, then if this is x first, if there is x first, then this will become x limit, and if there is y after, then this become y limit. So if x is first, then do the integration with respect to x first. So e to the power x is e to the power x. Now just put the limit and you will get the answer whatever will come after putting the limit. And after that, this is the constant, just take outside and do integration with respect to y, and after that e to the power y is e to the power y. Just put the limit and you get the desired answer. Leave here only, don't need to solve more than this, because we are interested in the concepts, not the hardcore theory. And this is the question. You can see x cube x plus y, this is the function, and here limit are constant. Then simple way, your x you are doing with respect to x first, and here you can see y limit is first. So you have to go with the back side, whatever dx is present, so do the y first, or if limit are constant, then you can say any of the way. So here you can see I did the y first, and after that x, you can do any of the way. So this is the homework for you. You have to try and the answer will come same. Now this is the question, and here you can see evaluate double integral with the region, and region is 0 comma 1 to 0 comma 2, and you know x y plane, x cross y means this is x limit, x is moving 0 to 1, and this is y limit 0 to 2, x is moving 0 to 1, y is moving 0 to 2, and your dA represent dx dy. Then just solve this in integral, and here you can clearly see So R represent the region in xy plane, and x is moving 0 to 1 and y is moving 0 to 2. Just put the limit, x is moving 0 to 1, y is moving 0 to 2, and do the integration. And if you are saying this is y limit, then you can say y first, and after that x. Just do the integration y first, keeping x is a constant. So if x is a constant, you are doing integration with respect to y, then this will give you x square y, because you are treating x as a constant. So x square y, and after that y square is y cube upon 3. Now just put the y limit, y moving 0 to 2, and after that just solve this, and after that do the integration. Just put the y limit only where y is present. So here if you will going to put, then you can clearly notice your upper limit 2x square, and after that 2 to the power 3 is 8 by 3. And if you're going to put 0, then this will give you 0, and this is also 0. That's why this is 0. Now you left with only the x. Now simple integration, just do the integration. Here you can clearly notice there is only simple integration, x to the power n, e to the power x, sin x, cos x. Only the simple integral you can notice here. So very easy to think the concept. Only you have to think where the limit is moving. So the integration of x square is x cube upon 3, and this is constant, so this will give you 8x. And now you can just put the x limit 0 to 1. Where is x present? Just put the upper limit minus lower limit. If you will put the upper limit, you will get whatever, and after that 0, just solve this, you will get the answer. And this is the homework for you. This is the surface, and r is moving, x is moving 0 to 1, and y is moving 0 to 2, and this is the region, and dA represent dx dy, or you can say dy dx. If you saying dy dx, just put the y limit first, y equal to 0 to 2. If limit are constant, then you can solve any of the way, but you have to think about the process. It is always good. And same way you have to solve this also. This is also homework. X limit, y limit. This is always x comma y, because this is the quadrant. So this is always x and this is always y, and you can easily solve this. And this represents the volume where x is moving 0 to 4, y is moving 0 to 2. So don't think about the theory. If exam in you so see the question, find the volume of the surface x equal z equal to x plus y plus 1, where x is moving 0 to 1 and y is moving 0 to 2. That is same this question. So question can be any of the way, but this is always easy. So this is the homework. You can clearly see, if you are saying dx dy, then just put the x limit first. Any of the way you can solve, because this is the constant. So any of the way you can solve, you can also try, answer will come same. So if you are saying dx dy, but you have to put the x limit first, and after that y. Now you can see, if you are saying with respect to y, then you have to put the y limit, and after that you can solve. So any of the way you can solve, you will reach the same answer. Now let's move on the next topic. This is the question for you. Find the volume under the plane just over the rectangle. This is the x limit, and this is the hint. You have to calculate x is moving 0 to 1, y is moving 0 to 2, and this is the surface. And if you are saying this is y, then put the y first. So integrate with respect to y, keeping x is a constant. If you are doing integration with respect to y, then x is a constant. If you are doing x first, then y is a constant. This is the simple logic you have to understand and do the integration. Find the volume under the surface this, and your region is rectangle. X is moving 2 to 3, y is moving 1 to 2, and this is the hint you can see. If you are saying dy dx, just put the y limit first, 1 to 2, and after that x 2 to 3. And if you are saying dx dy, then just put the x limit first, 2 to 3, and after that y limit. The answer will be same. You can try with yourself also. Now let's move on the type 2 variable limit. So this is the double integral we are going to solve, variable limit. And if this is not given, and this is the question you have, integration 0 to x xy dy dx, and clearly you can say this is dy. If dy is there, then you can imagine this should be y. Always not, but if there is not mention, then the limit most time by 99 time percent is y limit. So if already mentioned, then we cannot do anything. So if there is x, this is the limit in x, then it automatically become y limit. And if this is y, then the remaining one will be x limit. And you already know how to solve. If this is the variable, then just to solve variable limit first, and after that the constant limit. So if you are going to do variable limit, and you can see variable limit in x, so this is y limit, so do the integration with respect to y first. If you are doing integration with respect to y first, then mean x is a constant. If x is a constant, then integration of y is y square upon 2. Just put the upper limit minus lower limit. This is the y limit, y equal to 0 to x. Just put the limit here. So if you are going to put here, you have to put the limit only where is y. So here if you are going to put, then this will give you x. You can take outside, or either just directly you can put. So this will give you x cube upon 3 to 0 y 3, and after that this is remain only x. Then just do the integration, and after that you can reach with the answer. Same way you can solve this another way also. Now let's move on the next question. So the next question is xy dy dx, and this is the limit. X is, see here already mentioned or not, we don't know. And here you can see dy dx, then you cannot directly say this is y limit. You have to think about what is the limit in the variable. So here you can see this is present variable in term of y. If variable in term of y, that means you can say x equal to 2y, something like that, because y equal to something is not that much. So this is the limit of x. So your x is moving 0 to under root 2y, and if this is x limit, then now this become y limit. Now if you already clear with the limit, which one is x limit, which one is y limit, then it's easy to do. Just clear, if this is variable in y, that means this is x limit, and if this is x, then again this is y. So and you have to do the integration first to the variable limit. So if this is x limit, then just do the integration x first. So if you are going to do x first, that means y is a constant. So if y is a constant, then x square upon 2, x the integration x square upon 2, you can take y outside and just put the x limit. And if you are taking inside, then put only in the x only. So you can see y upon 2, I took the outside, and after that x square, just put the x limit, upper limit minus lower limit, and after that square, this under root will cancel out, you left with 2y. Now you can cancel 2 to 2, you left with y square. Now this is the y limit, just to do the integration with respect to y square become y cube upon 3, and now you can easily put the limit. So this is the way how you can solve the question if limit are variable. And here you can see this is variable limit in x, that means this is y limit. Now you have to treat what? You have to treat x is a constant. If this is variable in x, then mean this is y limit, and you have to do the integration with respect to y first. If you are going to do with respect to y first, because we want to finish the variable limit first, and after that we will go with the constant only. So remember these things. So if you are going to do with respect to y first, then just take like this, and now this become tan inverse x upon a, integration 1 upon a square plus x square dx. This will give you 1 upon a tan inverse x upon a. So same way you can imagine, you can say, because we have to do with respect to y first. So same way you can write, and after that 1 upon a, this is your constant, so 1 upon a tan inverse x upon a. Now just put the y limit, so upper limit minus lower limit. Now if you will put upper limit, then this is constant, this time just take outside. If you will put this, then this will give you 1, and you know pi by 4 give you 10, 1, and 0 is 0. So from here you will get pi by 4, and here you will get 0, and this is pi by 4 is constant. Then take this pi by 4 outside, and now you left with under root 1 plus x, 1 plus x. Either you can change x equal to tan theta, or either you can remember this formula, this formula 1 upon under root a square plus x square is log x plus under root x square plus a square. Just put this formula, upper limit minus lower limit, and you reach with the answer. So these are the some formula you have to understand. If a square plus x square, then this will give you 1 upon a tan inverse x upon a. If there is under root a square minus x square, then you already know sin inverse x upon a. There is no 1 upon a term will come. So this thing you have to remember. And if there is plus sign, then this will become log formula, log x plus under root x square plus a square. Either you can solve by putting x equal to tan theta. Also you can solve by this. What easy thing is, just remember this formula. And if there is x square minus a square, now this is log x plus x square minus a square. And if there is a square minus x square, then this formula is 2a, 1 upon 2a, a plus x upon a minus x. This is the golden formula you have to remember. This the formula you have to remember by also. If there is, you notice x square minus a square, then also you can take minus common, and after that the formula becomes same. And after that, if you want to multiply, then just reverse the log, you will get the same thing. And here you can notice some of the modulus term, that is fine. So now let's move on the next question. So our next question is like this, and here already if limit is given, then it is fine. And here if this is y limit, then just do the integration with respect to y first, because we want to remove the variable limit first. So if this is y limit, so just do the integration with respect to y and treating x is a constant. So if x is a constant, then this will give you, just first multiply, then only you it will be easy. Otherwise you have to take in multiply formula. So now just do with respect to y first. If you are doing with respect to y, then x is a constant, so x cube is already constant, so integration of this will give you x cube y. X square will give you y cube upon y square will give you y cube upon 3. Just put the y limit. What is the y limit? 0 to x. Just put the y limit 0 to x. Where is y present, only put y limit there only. So here upper limit, here upper limit. Now after that, if you will put the lower limit, because of this y, you will get 0 0, and now you can solve easily. and now it's remaining into the x only. Just solve, and after that just put the limit. So x4 by 3 you can take common, and integration of x4 will give you x 5.5. Now just put the limit and you will reach the answer, whatever the answer will be. Now there is the some type of question you have to notice. There is only region is given and you have to calculate the area. So this is the type third, but here is the question. So I am just going to show you. Calculate the area bounded by the curve y equal to x square and x equal to y square. Y equal to x square graph is like this, and x equal to y square graph is like this, and bounded region will be like this. So for solving, you have to first solve these two curve, and if you will solve, then you will get 2 0 comma 0 and 1 comma 1. And I already told you, you can find out by the single integral and double integral also. If you are going to do with the single integral, then what you have to do? Single integral, just say top curve minus bottom curve, top curve minus bottom curve. And if you are saying this is y equal to fx and this is y equal to fx, then just do with respect to x and put the x limit a to b whatever. And in our case, x is moving 0 to 1. You can clearly notice x is moving 0 to 1. And if x limit is constant, then just put the vertical strip. And if you are putting the vertical strip, then upper curve is what? Upper curve is, this is y equal to x square and this is x equal to y square. And here you have to put the equation in term of y only. Just remember this. So upper curve is, you can clearly notice, I can make the graph once again, then you can clearly notice here x square is this, and here you can notice the upper is what? This is your x equal to y square. So your y become under root x, and in this case, and this is x square, so y equal to x square. So upper curve is what? Upper curve is y equal to under root x. So under root x minus the lower curve is the lower boundary moving with along with this curve x square. So upper curve minus lower curve, and how x is moving? 0 to 1, 0 to 1. And also you can solve by the y also. So if you are saying with y, then y is moving 0 to 1, 0 to 1, because this is 1 comma 1. And now you have to put the equation in x. So again you have to take the vertical strip, horizontal strip now, because you are treating y as a constant. So in this case, your x equation is y square. Left, you can see left one, left minus this one equation. From here you will get under root y, and this is y limit 0 to 1. Then just do the integration with respect to y. You will reach the same answer. You can clearly notice. So this is the way how you can solve, any of the way you can solve the integral. See here, I already solved by the single integral. If you notice by the single integral, then by solving y equal to x square and x square y, this is the graph. And if you are first, you have to find out the intersection point. So just put any of the value. If you will put y here, then this will give you x equal to x square whole square. Just solve, you will get 0 comma 1. If you put x0 y0 x1 y1, so you get 0 comma 0 and 1 comma 1. So x is moving 0 to 1, and you have to find out the area of this region. So just solve. If you are using only single integral, then top curve minus bottom curve. So top curve, in this our case, top curve is what? Y equal to under root x, and bottom curve is along this x square. So under root x minus x square, just do the integration and you will get the answer. And if also you can do by the by limit also, I already tell you. Now just to come with the double integral part. If you are going to do with the double integral and you are saying dy dx, or either you can say dx dy. If you are saying dy dx, what you can do here? So you can do one thing. If you are taking x is a constant limit, then just treat y is variable. How y is moving? Here you are saying x is moving 0 to 1. It's fine, x is moving 0 to 1. Now you have to take y variable. You can take y equal to 0, but your y is not 0 because this is whole line, but y is moving along with the this. So lower side y is moving along with under root x. So lower side is under root x, and upper side is moving with this, sorry, lower side is moving along with this x square. So x square, and upper side of this strip is moving. You can clearly notice upper side is moving with the under root x. Now if this is y limit, then dy dx, and just do the integration. Simple way. And if you are want to do like this, then take y, how y is moving, same way. Y is moving 0 to 1. Now just check how x is moving. Same way you can do if you want to do. Now I'm not going to do again and again. So you can notice any of the way. So upper side x, upper side strip is moving along with under root y. So that's why upper limit is under root, sorry, y under root x. And lower side of strip is moving along with this x square. So lower limit of, and if this is variable in x, so that's why this is y limit. And how your x is moving 0 to 1, and just do with respect to y first, because this is y variable limit and y. So this is the way how you can find out the area by the double integral. This is the simple way. And if there is a region is given, then how you can find out the area? This is the second question. Evaluate the integral double integral d, and d is the region, and this region you have to, in this region you have to find out the area. And how you will find out the area c in this region? And there is two ways you can solve. Either you can say x is constant. If you are saying x is constant, so x is moving 0 to 2 comma 1, so x is moving 0 to 2, here x is 2. Now how y is moving? Just if x is constant, then you have to take vertical strip. See, if you will say y equal to 0, that means your y will start here, but your y is not 0, your y is moving along with this line. And what is this equation of line? Equation of line is x by 2. So your lower side of y is moving along with this line x by 2, and upper side is moving along with this y equal to 1, y equal to 1. So this is the variable limit in x. So just solve this equation and you will get the answer. But if there is function is present, then just do the integration of this function with respect to this region. So this is the way how you can solve. So you already know how to solve. So if there is a region is given, then you already know how to put the limit here. Now you already know x is moving 0 to 2, y is moving x by 2 to this. Now just do the integration. If you are doing with respect to, this is variable limit of y, so just do with respect to y, treating x is a constant. So you can easily do from here, x is a constant, so x square constant, e to the power y will become e to the power y, but you have to divide by the x. This is point 2 have to remember. And after that just put the y limit. If you will put the y limit, then you can just divide here, and after that just put where y is present, upper limit minus lower limit x by 2, you will left with this term. Now you can easily integrate these two terms separately, and any of the way just will give you first e to the power x integration, and after that x differentiation, e to the power x integration, after that again e to the power x integration. So you can remember integration of x e to the power x is what? X e to the power x minus e to the power x. This is the direct integration of x e to the power x. So after that you can put the limit here, and this here you can say this is u, and after that this now become the derivative is present, x dx now become du. If you want to say this is limit of u, then you have to change the limit. If you will put this is x limit still, and if you want to make this is u limit, then you have to change y from here. Up lower limit if you will put, then u will become x0, then u will give you what from here. If you will put here, then you will get u lower limit. So see, if you will put 0, then this u will give you 0, and if you will put what, if you will put 2 here, then 2 square upon 2 equal to u. So again upper limit is also 2. So you can change this 2, or either just solve and after that put the u value, and after that you can back substitute the x limit. So this is the way you can solve. See, after that I put the u value, and after that this now become x. Now I am going to put the x limit. Any of the way you can solve. So this is the way how you can solve the double integral if limits are variable. So now we have type third, and this is also important type. All are the important questions I'm going to cover in this session. So this is the type third. Evaluate integral bounded by the region. Means in this case you have to see the regions, and here you can see evaluate this integral double integral x y dx dy with in the following region. This is x plus y less than 1. You can notice this is nothing, y equal to minus x plus 1 line. See, minus x line is like this, and now this is tipped in the plus direction, one direction. So now this line is become like this, and now less than region. So you have to find out the this region. So if you will draw, then this will give you what 1 comma 0, and this will give you 0 comma 1. And clearly you can notice, if you are taking x limit constant, then x is moving 0 to 1, and y is, for y you have to take the strip, y is moving 0 to along with this line. And if you see the what is the equation of line, 1 minus x, y equation is 1 minus x. Now this become your limit, and just solve this integral. We already discussed if limit are variable, then how we will solve. So this is the way how you can solve the integral. Now let's discuss how you will solve this integral in this quadrant. And here you can see in the first quadrant. That's why I just strict myself in the first quadrant. Otherwise we have to go in the other quadrant also. So this thing you have to notice. Now come to this question. Next question is x square. This is the circle x square plus y square equal to a square. This is the circle, and the first quadrant is only this. And you already know center is 0 0 and radius is a. If this is a, then you can notice this is a comma 0 is the point. So x is moving 0 to a from here to here, and in the first quadrant, and y is moving along with the strip. So y is moving 0, and from here you can find out the equation under root a square minus x square, and your surface is xy, and this is y limit, so just say y and after that x. Just do with respect to y first and put the y limit, and after that x. We already discussed how we will solve. So you can solve, I will say easily, then you can easily do. See, y square upon 2, integration of y is what? Integration of y is y square upon 2. Just put the upper limit minus lower limit. Clearly you can see upper limit. Now if you will put, and the root will cancel, 0 will give you 0. Now it's remaining this, just multiply, and after that just do the integration. So this is basic integration you can notice. Now after, if you will put, then you will get the answer. So this is the very easy question you can do. Now next question is, evaluate this integral, and the region is bounded by the y equal to x square. We already know y equal to x square graph is this, and under root x is this, and this is the bounded region. And if you will solve, then again you will get 0 comma 0 and 1 comma 1. So if you want to do, then either you can say x is constant. If x is constant, then you can say x is moving 0 to 1, and y is moving along with this strip. And if you will say the lower side of strip moving along with this x square, so you can say x square, and upper side is moving with this x, and this is your surface x plus 2y, and now this is y, then you can say dy dx. Just solve this integral and you will done. So this is the easy way how you can solve. So first solve and find out the intersection point. Again 0 comma 1, 0 0 will come, and y is the lower limit moving along with this under root x square, and after that under root x. So this is the way how you can solve the question. So very easy, I'm not going to waste my time. So now this is the next question. Evaluate this integral, and the region is bounded by the y equal to x, y equal to 2yx, and x plus y equal to 2. X plus y equal to 2, you can say minus x plus 2. So you already know y equal to x line is passing like this. So, and you already know y equal to, you already know what you know, I don't know, y equal to minus x plus 2. So you can say y equal to minus x is passing through the origin, but you now shifted at 2 distance. So this is 2 comma 0, and this is 0 comma 2. This is the x plus y equal to 2 line. Now y equal to 2x, y equal to x is passing through the origin. Y equal to 2x, how you can say? You can say if x is 1, then your y will be 2, means from here your y equal to 2x line will pass. So the intersection region will be this. So this is the region you have to cover. So how you can find out here the integral? See, if you going to find out the integral, then there is a problem you can face here. See, if you going to do, then what thing you have to face, let me show you. See here, from here to here you are moving, x is moving 0 to, if you find out by solving these two lines, then you can easily find out the quadrant of this. X is moving 0 to 2 by 3, and if you will draw the vertical strip, then y is moving along with this line, y is moving x to upper side of this, whatever is, I think, what is the equation of this line is 2x. So upper side is 2x from in this region. But the problem is, if you just after 2 by 3 to 1, you if you will draw the vertical strip, then lower side is still moving 2 to 3, x is 2 to 3 to 1, and y is moving, lower side is still moving y equal to x, but upper side is now moving along with this line x plus y equal to 2. So y equal to 2 minus x. So this is the problem you will face. So if you will do with respect to treating x limit is constant, then you have to divide into the two portion, then only you can solve, otherwise it will be wrong. So this is the way how you can solve this question. And how you will find the point? So very easy, you can notice these two equations. If you will solve these two equations, this is x plus y plus 2. If you will solve this two equation, just put the y value 2 here, y value is 2x, just put here, then this will give you 3x equal to 2. So x is 2 by 3, just put 2 by 3 either here, sorry here, then you will get the point here. What point you will notice? If you will put x value here, then your y value become 2 into 2 by 3, 4 by 3. So your point will become 2 by 3 comma 4 by 3, means x is moving 0 to 2 comma 3. So x is moving 0 to here, 0 to, x is moving 0 to 2 comma 3, and y is moving along with this line. Y is moving, see, y is not 0, moving is this line, y equal to x, and upper side is moving with 2x, and after that just x dy dx plus in this curve, and in this curve, this curve is done. Now just come to this curve, and if you are going to come in this curve, then see, integration x is moving 2 by 3 to 1, x is moving 2 by 3 to 1, and how y is moving, just draw the vertical strip. if you will draw the vertical, y is moving along with this y equal to x, and the upper side is moving along with this line x plus y equal to 2, your y will become 2 minus x. Just do the integration, these two integration, and you done. So this is the way how you can solve the question if the region is given. See, just divide into the two portion, just directly you can say, no need to give the name, directly put the limit, two way, and directly you can solve. So this is the way how you can solve. After that, this is simple question. Now this becomes simple type 2 if limit are variable. Now just solve and you have done. Now same way you can solve, taking y as constant and x is variable. Same way you can do. It's one way sufficient, so I'm not going to explain now again, but it's fine. If you are see, the point is what, if you will solve these two, y equal to x and x plus y 2, just put here y equal to x, you will get x plus x equal to 2, so 2x equal to 2, x equal to 1, x equal to 1. If you will put x equal to 1 here, so you will get 1 comma 1. So your y is moving, see in this, y is moving 0 to 1 from here to here, and how x is moving, just draw the horizontal line. So x is moving along with this, so x is moving y upon 2, and the upper side of x is moving from here y. This is the first region. In this region again, whatever the value will come here, I don't know what was that. Integral is what, integral was x, so just put value here x, and this is x limit, then just do x first, plus. Now just come to this portion. In this portion, if you will see, then how you will solve here in this portion, just to see y, how y is moving here to here. So after that, y is moving 1 to 4y. See, we have to go till only here, not till this point. So here to here, y is moving 1 to 4 by 3, and after that how x is moving, because we have to take the horizontal step, x is moving still along with this line 2x. So the lower limit x is y upon 2, and along with this line you can clearly notice x value will be 2 minus y. Now x was the surface, and now dx dy, just solve this and you done. You can clearly notice here, this is the way how you can solve, and you will get the same answer. So same answer you will get. So this is the way how you can solve the question. So now let's move on the next topic. So this is the homework you can easily do. We already know this is x limit, y limit, just put the x limit, y limit, and just do the integration. If this is x, then just do with respect to x, keeping y is a constant. Same way you can solve this if region is given, and you can clearly notice this question we already discussed. Now let's move on the next question. So this is the type 4, and what is the type 4? Type 4 is nothing, change the order of integration. And why we require the needing to change the order of integration? Sometime what happened, we cannot solve in one order, and if we change, see this is tell the order first, you have to do with respect to y, and after that x. Now if you want to change this order, and if limit are variable, then you cannot do directly. If limit are constant, then you can say any of the way, because answer will come same. But if limit are variable, then you cannot change the order directly. First what you have to do, first you have to draw the region, and only after that you can change the order. This is y first, and after that x, then only you can change the order. So let's see how we can do and how we can solve. So this is the question here. You have to see, this is the limit in x, so this is y limit, and after, if this is y, then this is x limit. And now you have to integrate this sine y square first, and clearly you can see, if you are going to do with respect to y first, then you don't know the integration of sine y square, obviously, and anybody cannot do. So what we can do here, first draw the region. So our region is x is moving 0 to 1, x is moving 0 to 1, y is moving y equal to x 2, y equal to 1. So just draw the line x equal to 0. We already know, if this is the quadrant, x equal to 0 means y axis, y axis means x equal to 0, this is x equal to 0. X equal to 1 means just at distance 1 parallel to y axis, this is x equal to 1. Now come y equal to x passing through the origin. Now y equal to 1 at the distance 1, if you will draw, then this region will cover. Now you might be confused which region you have to take, this inner side, this lower side, or upper side. Just see the limit, how limit is moving. See, x is 0 to 1 means x is constant, so just take x is constant, so it can be this region or upper side region. Let's see, x is moving 0 to 1. Now see how y is moving. Y is not moving 0. If y will move 0, then your region will be this region. Now your y is moving along with this line, y equal to x, means the lower side moving along with this. So means this is your actual region in which you have to find out. So your region, actual region is this region, 0, y equal to x to 1. So in this region we have to find out the integral value. So see, now if you are going to change the order, then what you have to do? See, x is constant and you are taking vertical step. Now just to convert this, x is moving 0 to 1, and in this region your y is moving 0 to 1. Now just convert constant x to y constant. Y is moving 0 to 1. Now how x is moving? If this is vertical strip, then take horizontal strip. How x is moving? This is x equal to 0 line, and along with this line y equal to x, then x equal to y, sine y square dx dy. Now this become x limit. Now if you will do with respect to x first, then integration of dx will give you what? X. If you will put upper limit y, now after that you can easily solve this integral. So sometimes it integral become difficult to solve or impossible to solve, then we will use the change of order of integration. Change of order means you are changing the order of integration. Change of variable is different. You will change the variable. We will discuss the change of variable, but we will discuss only the Cartesian to polar, means xy to r and theta. So this is the way how you can solve the question. See, so first of all you have to draw the region, and after that, if this is the vertical strip, then just make this horizontal strip. Vertical strip means x constant, y is variable. Now just to convert the y constant x variable, means y is moving 0 to 1, and how x is moving? Lower side is moving x equal to 0, and upper side is moving x equal to y, and now your integral order will come dx dy. Then this will be easy. So see how we will write the solution. So first draw the region, and now just draw the region. This is the region, simple. X equal to 0 is this, and this is y equal to 1 at distance y, and this is at distance x equal to 1. So this is the line, and y equal to x is the line, and this is the region. Why the integral you can notice, because you are saying x is moving 0 to 1 and y is moving y equal to x. So this upper region is our region. Now just vertical strip just convert into the horizontal strip. Now your x is constant. Now just make y constant. Y is moving 0 to 1, and just see how x is moving. X is moving 0 to y. X is moving 0 to y. Now your order is reversed. Now you can easily integrate because y is constant. So if y is constant, then just do the integration with respect to x first. So this will give you x. Now just put the upper limit minus lower limit. So this will give you y minus 0. Now you left with y sine y square. Now you can easily say y square is equal to u. So if you are saying y square equal to u, this will give you 2y dy equal to du. So you can say y dy equal to du upon 2. So just put y dy equal to du upon 2. Now if you want to convert into the limit in u, then easily just put here lower limit of y, then this will give you lower limit of u. Upper limit of y, this will give you upper limit of u, and you are left with sine u du. And here du by 2, just put dy y dy value. So just do the integration, and whatever will come. See, don't do the silly mistake. The integration of differentiation of sine is positive cos x, so integration is negative. So just to remember this thing. So let's move on the next question. So our next question is this: evaluate this integral 0 to 2 y x y by 2 e to the power x square dx dy. See, this is with respect to y, so this is x limit and dx dy. So here you cannot do directly because you don't know the e to the power x square integration. So what you have to do, just change the order, because in the exam you might notice the question will not come by saying change the order. You have to think how you can solve. So first draw the region. Your y is 0 to 2, y is 0 to 2, and x is y by 2 to 1. So you can say y by 2 to y equal to 2x. So see, y equal to 0, if you just draw this, y equal to 0 means this x-axis, and y equal to 2 means at distance 2. This is the line y equal to 2, and after that y equal to 2x. If this is y equal to x line, then y equal to 2x will be like this, and x equal to 1. X equal to 1 means one distance. So if you will notice, then this is the region. Don't just remove this line. This is not our line. So our region will be like this. I think this region we have to find out the integral. So this is the way how you can draw the region quickly. So if this is the region, and in this region you can clearly notice, see, y is constant. Y is constant means y is constant, like y is moving 0 to 2, and after that, after solving, see what is the intersection. This is the intersection, and also this is the intersection. So if you will solve, then you will reach this point 1 comma 2, means x is moving 0 to 1. This is the first quadrant of x, and y is moving 0 to 2. This is the second quadrant of y. So x is moving 0 to 1 and y is moving 0 to 2. So you can clearly notice y is moving 0 to 2 and x is moving y upon 2. You can say 2x, means x is moving, the lower side of x is moving along with y equal to 2x. So your region should be, see, there is a mistake is here in this question. Your x is moving along with this line, the lower side. So your region should be this region, not this region. So there is a mistake I did here. This region is not your region. Your region is x is moving. See, your x is moving this or this. Clearly if you will take x equal to 0, that means you will take this region, and here your x is not moving 0, x is moving along with this line, so lower limit of x is moving here. So just remember how you will specify the region, otherwise everything will go wrong. So just make sure you will not do the silly mistake while deciding which region is your region. So if you are taking the y constant, then you have to take vertical strip, and if y constant, then take vertical strip. If x constant, then take horizontal strip. I said the wrong. If you are taking y constant, then just take the horizontal strip, and if x constant, then take the vertical strip. This is the simple logic what we will thinking. So after drawing the region, which region is your region, just see by the limit. So y is moving 0 to 2, just draw the horizontal, means x is moving y by 2 to 1. So this is your required region. Now just to convert into the y limit constant, just convert into the x limit constant. X is moving 0, see x is moving here to here, so x is moving 0 to 1, so x is moving 0 to 1, so x is moving 0 to 1, so x is moving 0 to 1. And how y is moving? So just draw the vertical strip. Y is moving lower side 0, and upper side y is till 2x, and your actual equation is x square d. Now it's become dy dx. Just do the integration with respect to y first. If you will do with respect to y first, because x is constant, so this constant will remain same. Now you left with dy, integration dy is y, then just put the y limit, y equal to 0 to 2x, just put the 2x first, then this will give you 2x minus 0, x square dx you will left, and your x will move in 0 to 1. And clearly you can notice here derivative is present. Now you can do the integration easily. So this is the how you can solve the change of order of the limit, change of order. So see, first draw the region, y equal to 0 by 2, y equal to 0 to 2, and after that this line, this is the region. Just change the line. Now your x is moving 0 to 1, and y is moving y equal to 0 to y equal to 2x, and after that just do the integration and done. This is the way how quickly you can solve. So this is the way how you can solve this. And if you will draw this region, here you have to only change the limit order of the integration, no need to solve in this question. Here only change the limit. See, y equal to 0 to 4, y equal to 0 to 4, and this is under root y. If this is variable in y, that means this is x limit. So y is moving 0 to 4 and x is moving under root y. Under root y means if you do the square, then this will give you x square, but x equal to under root y on the y axis, this is only like this, like same under root x like this, and under root y like this, not go like this, because this is under root y, so it will not go in this direction, because only positive y, so you can say, but you have to still go with the logic. So your under root y graph is like this, and if you will solve under root y, see, and y is moving 0 to 4. Okay, y is moving 0 to 4. 0 is this, y equal to 0, and y equal to 4 is the line. This is y equal to 0 line, y equal to 4 line. Now x is moving this, so x is moving this. X equal to 2, where x equal to 2? Here inside, crossing this line, just check. This is the equation, x equal to under root y. If you will put x equal to 2, then under root y, so this will give you y equal to 4. Means this point x equal to 2, your y value is 4, means if your x is 2, then y should be 4, means this is the point 2 comma 4, means this x equal to 2 line will pass from here, means this is the actual graph you can notice. And the region you can clearly see, y is moving 0 to 4, and if y is constant, then you have to draw the vertical horizontal strip. And if you will notice, if your x will start from here, then it should be 0, but your x is moving the lower boundary, then your required region is this region is your required region, not the this region is not. This is the required region, because x is moving under root y to 2. X is moving under root y to 2. Now if you will change the order, then what will happen? Now this time your, now this time is what? This time your y is constant. Now just convert into the x constant. So how your x is moving? See, x is moving from here to here, and the equation is 2. So x is moving 0 to 2. Clearly you can notice from here. And now just draw the vertical strip. How your y is moving? Y is moving 0 to along with this curve. And what is this curve? If this is x equal to under root y, then y equal to x square. So y is moving along with the x square. So this is the equation you can notice. So what only you have to change the order of limit, and that is done. This is asked in the question. No need to solve because it's not that much easy to solve. So sometime you can notice only you have to change the order, and that's left. So this is the third type. Fourth type we already discussed here, how you can solve the question after changing the order of integration. Now next move on the next type. So here we already discussed why I change the order of integration. Sometimes integration in one order is difficult or impossible to evaluate, but when using change the order of integration become manageable. So we use like that only. So our type 5 is calculate the area via double integral. We already know if you just put function equal to 1, then this will give you what? Area. And we already discussed this question, so we are going to very fast. Find the area bounded by the y equal to x square and y equal to 2x line. You already know y equal to x square is this and y equal to 2x if this is y equal to x line. So similar you can notice, and if you will solve these two equation, you can see what the value will come. Just put the 2x here, x square, you will get the x value. So if you see x square minus 2x equal to 0, x equal to 0, x equal to 2. So this is 0 comma 0 and this x is 2 here. And if you're going to solve, no need to find out y because you already know the x limit. So you can say x is moving 0 to 2, and how your y is moving. See, y is moving, the lower side of y is moving along with this curve x square. So you can say y equal to x square, and upper side of curve moving along with this line 2x. So y equal to 2x, and this is dy dx. Simple, you can solve by the double integral. If you want to solve by the single integral, then you can say x is moving 0 to 2, and top curve is what? Top curve is 2x, and the bottom curve is what? X square. And just do the integration, and this is the so simple integration is there left. So this is the way how you can solve this question. I'm not going to solve again and again. You can see just do the integration, simple, and you can easily find out. Now come to the next question. Y equal to x, y equal to 2x, and y equal to 0. So here you can clearly notice y equal to x, y equal to 2 minus x, and y equal to 0. Find the area bounded by this. Y equal to x, you already know y equal to x line is this. Y equal to minus x plus 2. This is a minus x plus 2. Minus x you know like this, and plus 2 means upper side like this. Now y equal to 0 means x is y is 0 means this is the common area is remaining, y equal to 0, and this is the equation y equal to x, and this is the equation y equal to minus x plus 2. This is the region area you have to evaluate. But in the question is particularly asked find y the double integral, then you can go with the double integral, and if nothing, then you can notice this is nothing, this is the triangle, and you know the area of the triangle is 1 by 2 base into height. So base is what? Base is from here to here. Just solve these two equations, y equal to 0, and this is the minus x plus 2. If you just put 0 here, you will get x equal to 2. So here to here 2. So base is 2, and height, if you will solve these two equations, y equal to x, if you will put, then this will give you x equal to 1. So point is 1 comma 1 means x is 1 and y is 1. So height is 1. This is telling you y is 1. So area is 1. So this is come by direct answer. Now let's move on the double integral part. So how we can solve by the double integral. So see how you can solve by the double integral. First just draw the region, and let's see how we can solve. So y equal to minus x plus 2 is like this, and y equal to x line is this, and y equal to 0 is this. And if you will solve y equal to x and minus 2 plus x, you will get the intersection point. This is 1 comma 1. And see, if you're going to find out the region, then see from here to here this is different, and here to here this is different. Why this is different? Because see, here to here x is 1. So your x, if you are taking x is a constant, then x is moving 0 to 1 in this region, and you have to draw x constant means vertical strip. How y is moving? Y is moving 0 to, see, y is moving 0 to along with this line x, and dy dx plus double in. See, if you move after 1 means x equal to 1 to 2, because you are going till here x is 2, and how your y is moving, see, still y is 0, and now your y is moving along with this line minus 2 plus x. See, sorry, y is moving minus x plus 2, sorry, minus x plus 2. So you can say 2 minus x, that is also fine. So after that, if you will solve these two integral, then you can get the area of this, and this area will be 1. Directly you can notice. Either what you can do, either you can draw, see, if you will draw this region, and this is your required region, either you can solve by the y, because you already know 1 comma 1. So you can see y is moving 0 to 1, and how your x is moving. See, if you just draw the y is constant, then you have to draw the horizontal strip. So if you draw the horizontal strip, then x is moving along with this line y equal to x, and this is what 2 minus x. So the lower side is moving, see, lower side is moving along with this line y equal to x, so y equal to x, and the upper side is moving along with this, sorry, here you have to write the equation of x, so you have to say x equal to y, and x equation from here, if you're going to find, then x will come this side, x equal to 2 minus y, 2 minus y. Now this is x limit dx dy. So if you will solve this integral, then also you will get the answer. So here is the three way I just tell you how you can solve this integral. So clearly, if you will going to solve, then you can clearly notice. So this is the way. When your x is constant, then you have to divide into the two portion. See, you have to divide into the two portion, and after that, if you're going to integrate, then you will get the same answer 1. And if you are taking y limit constant, x limit variable, then see, y limit means here to here, 0 to 1, and x is moving along with this, x equal to lower side is moving along with this, upper side is moving along with this. So if you will solve, then you will get again 1. And the third method we already discussed, base into height 1 by 2. So this is the third method also you can find out. This is the question homework. Find the area bounded by these two curves. See how you can solve. Y equal to x square is this, y equal to x square, and this is y equal to x. So y equal to x you already know. X plus 2 means just the 2 distance upper side, means you have to find out this area. If you will notice, then here to here you have to find out, I think this is -1, and let's say this is 2. After solving, you can, if you will solve these two, then you just put the y value here, x plus 2 equal to x square. If you will solve, then you can get x value. So 2x value, -1 to 2, let's say in this case. And how your y is moving, just take the vertical step. So lower side is moving along with this x square, and upper side is moving along with this line y equal to x plus 2, x plus 2, x square. And you are finding the area, so just say dy dx, because this is y limit and this is x limit. So this is the way how you can find out the area in this particular case. See, I think I already solved this question. See, if you will solve, then you will get the limit here, x equal to -1, x equal to 2. If you will solve the equation, then you will get, see, if you will solve by this is quadratic equation, easily you can solve. So you will get 2 comma -1. So 2 is on the positive side and -1 is the in the negative side. So x is -1 to 2, and y is moving lower side x square, and the upper side is moving along with this. So you can easily do by this. Also you can do like this also. So any of the way, it's up to you. I'm not going to do too many complex things. So now if you find the area bounded by this region, then you can clearly notice y equal to x under root x is this, and y equal to under root y equal to 0 is this, and x equal to 4 at the distance 4, means this you have to find out this region. See, if you going to, x is moving 0 to 4 and y is moving 0, the lower side is 0 and upper side moving along with this curve. So y equal to 0 and upper side is moving along with this curve under root x, and this is y limit. So dy dx, just do the integration. If you do with respect to y, y will come under root x 0 to 4 dx, x power 3 by 2 upon 3 by 2, just put the 0 to 4 upper limit, and you done. That's the way you can do. So this is the homework for you, just try. So now let's move on the next type. Our next type is type 6, change the variable in integration. Change of variable means here we will just discuss only the Cartesian plane to polar plane, means xy plane to polar plane. For changing xy plane to polar plane, you need to remember x equal to r cos theta, y equal to r sin theta we are going to put. So x square plus y square will become r square, and tan theta become y equal to x. If you see, if you just divide x by y, then this will give you cos theta upon sin theta, because cancel out, then x upon y, you can say, you can write y upon x, then this sin upon theta will become tan theta. So this is the way this equation are come from this side. So if you are going to do, then dx dy will become r dr d theta. This r comes from the Jacobian factor we already discussed in the Jacobian chapter, so I'm not going to in detail. I'm just going to very fast because this is the revision lecture. So see, evaluate this integral dx square y square. Here I can say dA also instead of dx dy. R is the region bounded by this circle, x square plus y square equal to a square. So if you are going to evaluate, then directly you can see, if you are not going to use the polar coordinate, then what will happen? So see, you know the circle, and x is, you can say x is moving -a to a. Simply you can say x is moving -a to a, and y is moving, the lower side of y is moving. Here you can say minus under root a square minus x square. Upper side is a square minus x square, and after that this whole, and after that y dx, you can say like that. But if you are going to integrate, then it will become complex, so it's better to change the variable. So sometime in the integration, change of variable will become easy, so you have to use change of variable also. So if you notice x square plus y square, then just you can go with the polar coordinate. So see, our original question was this, and our region was this circle. See, If you just put x square instead of x square y square, just put x equal to r cos theta, y equal to r sin theta, then x square plus y square become r square. Dx dy you can put r dr d theta, and you have to integrate over all this circle, means whole circle, and you know radius is 0 to a, then you can say r is moving 0 to a. And how your theta is moving? See, theta is 0 to 90, after that 180, after that 270, after that 360. So whole circle will cover if your theta will move 0 to 2 pi. 2 pi means 360. So your range, your theta range is 0 to 2 pi, and r is 0 to a. So this is the now limit will become r is 0 to a, theta is 0 to 2 pi inside this circle. So you will evaluate overall this circle. Inside this circle you can easily integrate. So r is moving 0 to a, theta is moving 0 to 2 pi, and this is constant, so you can do any of the way first. So now it's become easy. Just to do with respect to r first or theta first, it's up to you. If you are going to do with respect to theta, just put the theta limit. 2 pi constant, just take 2 pi constant outside. Now just do with respect to r cube will become r4 upon 4. Just put the upper limit, lower limit, then you can just divide, you can take, just put, and then. So this is the way how you can solve. Now evaluate this integral over the region in entire xy plane. Entire xy plane means x is minus infinity to plus infinity, y is minus infinity to plus infinity, means entire xy plane. And this you can clearly notice. If you are going to do, then it's become very hectic, because x is minus infinity to infinity, y is minus infinity to infinity. You can say minus x square e to the power minus y square dx dy limit are constant. You can do any of the way, but it is impossible to do the integration if the derivative is not present. So what we can do here, also you cannot do the change of order, still you will face the problem. So it's better to change the change the variable. So just you notice somewhere x square y square, just go with the polar, x equal to r cos theta, y equal to r sin theta, and x square y square equal to r square. So just use the polar coordinate. So your x square y square become r square, and dx dy become r dr d theta. And entire xy plane, see, if you are going to draw a circle which cover entire xy plane, means r is 0 to infinite, because you have to go till infinite. And if your r is infinite, now you have to cover whole entire xy plane. So if you are going theta 0 to 90, then this will give you only first quadrant. In the second quadrant, theta is till second quadrant, theta is 180. So same way for overall covering xy plane, theta will be 0 to 2 pi. And if in their question if said like this, you have to, and instead of entire the first quadrant, then your theta limit will be 0 to pi by 2, and r will be 0 to infinite still, because you have to cover this positive x-axis. So this is the, you can understand like this. So just see, just to replace, instead of x square y square, you can say r square, and r dr d theta you can say dx dy, you can say r dr d theta, and theta limit 0 to 2 pi, because you have to cover entire xy plane. So theta is 0 to 2 pi, and r is 0 to infinity. So now these are the limit. So just put, you can clearly notice the derivative is present. Now you can do the integration. Just say r square is u, then 2r dr become du, r dr now it's give you du by 2. If you want to convert the lower limit, just put the lower limit, u will become 0. So lower limit of u, infinity square is infinity, so upper limit is u become infinity, and dr rdr you can say du upon 2, and you can solve easily. How you can solve, it's up to you. So this 2 to cancel, pi, now just e to the power minus u is e to the power minus u, and also integration after that you have to divide by minus 1, or you can say minus will come upper side. So e to the power minus u is integration is minus e to the power minus u. Just put the upper limit minus lower limit. If you put upper limit, e to the power minus infinity is 0, e to the power infinity is infinity, e to the power minus infinity is 0, e to the power 0 is 1. So this will give you 0 minus 1, minus outside, so you get pi. So this is the way how you can solve. So next question is, evaluate this integral where r is the positive side of this disk x plus y square. So see, this is the circle whose radius is 2, because this is r square, so not 4, 2. Just remember this. So this is the radius, and positive quadrant is what? This is first quadrant is positive. So r is 0 to 2, and theta is positive quadrant, means 0 to pi by 2. So r limit and theta limit you already know. Just put value here, and done. X equal to r cos theta, y equal to r sin theta. R limit is 0 to 2, theta limit is 0 to pi by 2 in the first quadrant, and done. So this is the way how you can solve in this circle. And if you're going to do with the Cartesian plane, then see, if you are going to do with Cartesian, then also you can do. But in this case, your if you are taking x is a constant, then 0 to 2, then y is moving along with this strip, y equal to 0, because it start from here, and upper is moving along with this 4 minus x square. So this is the way. After that you can solve dy dx, but here already right, not written, then you can do any of the way. But polar, if you want to do, then you can do directly dx dy, just put r dr d theta, and r is 0 to 2, theta is 0 to 2 pi. Now it's become like this, and after that just do with r first or theta first, it's up to you, and after that you can solve, so you will get the answer. So this is up to you. So Cartesian also I already completed, so you can check Cartesian also. If you will do, then this will be y square upon 2 upper limit minus lower limit, then you can clearly notice, just multiply, and after that you can solve. So this is the way how you can solve. So this is the next question. Evaluate integral 0 to 1 0 to under root 1 minus x square e to the power minus x square y square dy dx. See, it's also very hard to evaluate. So what you can do, see, this is variable in x, so this is y limit and this is x limit. So y equal to under root 1 minus x square means you can say y square equal to 1 minus x square. You can say x square plus y square equal to 1 means circle whose radius is 1, and clearly x is moving 0 to 1 means x is moving 0 to 1, y is moving 0 to means upper half. This upper half plane you have to evaluate this integral. So if you are just using polar quadrant, then your r becomes 0 to 1 and theta becomes 0 to pi by 2. Just if you just replace, so this becomes e to the power minus r square r dr d theta, and your r limit is 0 to, see, from here you can notice 0 to 1, and theta is what, because the limit you can see this is only first quadrant, so 0 to pi by 2. Just do the integration and then, so it's so easy, so you can do directly. So after solving this you will get the answer, so I'm not going to solve again. So this is up to you. This is again homework. So if you are going to solve, just say this is r square, under root will cancel out, here you can say r dr d theta, and see r is the disk, and whole disk you are going to take, then your r become 0 to, for this disk 3, because this is the radius 3 square, and theta is whole disk means 0 to 2 pi. So after integration you can easily do. Same way here you can say this is y limit because variable in x, this is x limit, and if you are going to solve, then see, this is complete circle. If you will solve, this will give you x square plus y square equal to 1. So this is the circle, and here by the limit you can say whole circle you have to cover, because minus 1 to 1, and after that the strip is this whole circle you have to cover. So you can notice for whole circles your r will be what, 0 to 1, 0 to 1, and theta will be 0 to 2 pi. So, and just convert this question into the r and theta. So this will give you r square, theta by 3 by 2, so this will cancel, so this will give you r cube, and here you can say r dr d theta, and your r limit is what, 0 to, for this circle 1, and theta is whole complete circle you are going to cover, so theta is 0 to 2 pi, and now this will be r4, and after that you can easily integrate. So this is the way how you can easily solve this question. So this is the our second last type. Now just move on the next question. So next question is last type, triple integral, and in the triple integral also there is constant limit and variable limit. So if limit are constant, then same way you can notice, if this is dz dx dy, then you can say z x y, or you can say any of the way, because limit are constant. So just if you are doing with respect to z, treating y, x and y is a constant. So if you are treating x and y is a constant, that means x integration is xz, y integration is yz, z integration is z square upon 2, and the z limit 0 to 1. Where is z present, just put limit here only. If you put upper limit, then this will give you 1 1 and 1 by 2. So this is now become x and y. Now this, here you have to integrate with respect to x first. So now y and other are constant, so x integration is x square upon 2, y become yx, because y is constant, and here 1 by 2 x, so you can say x by 2. Now just put the x limit, where is x present, just put, so this will give you 4 by 2 means 2, 2x 2y, and this 2 by 2 means 1, and 0 will give you 0. So I'm not going to write again. So now with respect to y, then this will give you 2y, y square upon 2, y, just put the upper limit minus lower limit, you will. So this is the way how you can solve the triple integral with constant limit. Same way you can solve like this. If surface is there, then see, this is dx, so this is, you can say x, this is y, you can say this is y, this is z, you can say z. If already present, then you can go with this, but integration you can do any of the way, because limit are constant. So either you can do x first, then just put the x limit only, but don't miss anything. If you are going to do, if limit are already given, if limit are already constant, then what you can do, see, if limit are already given, then just dx means x is variable, other are constant, so this will give you x cube upon 3, y and z constant, just put the x limit, x limit is 0 to 1. If you will put 1, then this will give you 1 by 3 yz. Now just do with respect to y, dy dz, so this will give you 1 by 3 y square upon 2, put the y limit. So again after that z will left, then you can do like that only. So see, this will give you x cube upon 3 upper limit, so if you will put 1 by 3 will come outside. Now it's left with this. Now y will become y square upon 2, just put the y limit. Now after that you left with upper limit. If you will put, then this will give you what, 2. So 2 will come outside. Now z dz, just put the z limit. Z square upon 2, just put the z limit. So whatever answer will come, you reach with the answer. So this is the way how you can solve the triple integral. Also for this, just divide into the e to the power x, e to the power y, e to the power z. Same way you can solve. First you can do, if not given, then you can say this is x, this is y, this is z. So just do the integration. X first, y and z is constant, so just put the x limit, and this is constant, just take outside. And after that, just do with respect to y, put the y limit. Whatever will come, just take, that is also outside. And after that, just do with respect to z. So that is the way how you can solve the triple integral if constant limit. Now see the question, if limit are variable, it's not given, then see, if this is function of x y, that means this is z limit, and this is only the y, that means this is x limit. So clearly you can notice from here, this is x y, that means this is z limit, and this is now z, and this is x, then this is y limit, and if z and y is completed, then this is x limit. So see z, so just to do tz, so this give you 1 minus y, so just put upper limit minus lower limit, will become 0. So you left with this. Just now same double integral, now it's become double integral. So this is y limit. So if you are doing with respect to y, then treating x is a constant and other is also constant, means y is variable only. So integration of 1 is y, integration of x is xy, integration of y is y square upon 2. Just put the upper limit 0, upper limit minus lower limit. So where is y present, just put 1 minus x. So 1 minus x, 1 minus x, wherever is y present, just put 1 minus x. So for going to integrate again, just better to solve. After solving, you can do the integration any of the way, it's up to you. Just to now become only in one variable, just do the integration, simple integration, and just put the limit, and you will get the answer. Same here. See, this is z first. If you want to say z, then it's no regret to say y limit, and this now again become x. So it's simple. And after that, you already know how to integrate. If you are going to do with respect to z, that means other are constant. So just put upper limit, you will left with 1 minus y. Now it's become double integral. Only the y is constant, other are variable. So y minus y square upon 2. Just put the y limit, upper limit, where is y present. So see now, if you will just solve, then this will give you 2 minus 1 means 1 by 2. Or you can solve by, this is x square, not, so you cannot say like that. So it's better to open the integral square, then you can solve. So it's up to you how you will solve. So this is the question, how you can solve. So this is the homework, evaluate this triple integral. And dv is region, so this is x y z. So x is moving 0 to 1, y is moving 0 to 1, again z is moving 0 to 1, and this is the surface x plus y plus z. And if this is z, then start with z, and after that y, then say y, and after that z. You have to start with the nearest thing. So if you are doing with respect to that, treat x and y is the constant, and just put the limit, and after that you left with only whatever. If you want to say x first, then also you can say z y x. So any of the way you can say. If you want to say z y x, then also you can do. So any of the way you can solve. So it's up to you. So here also you can notice, for this integral, here you can do, if you want to say for this, you can divide into e to the power x, e to the power y, e to the power z, and x y z. If you want to say x is moving 0 to 7, y is moving 0 to 4, and z is moving 0 to 1, then you can say e to the power x, e to the power y, e to the power z. Here is z, then start with z, after that y, and after that x. If you want to say like this, z, if you want to say like z, and after that what, y, and after that x, then you can say dx dy dz. Any of the way you can start, it's up to you. So this is the easy way how you can solve the any of the question. So this is the last type. So I hope this lecture will be helpful for you in the preparation, anything, and revision of this topic, and you will acknowledge my effort. So thanks for today. Thank you guys.